Hey, yeah. For Thanksgiving dinner, you're gonna make that soup, right? That tomato soup. So that's 1 can of tomato soup with 1 can of water, right? Yeah. Except that's just for the two of us. So since there's gonna be 10 people, you're gonna need 5 cans of soup for 5 cans of water. Got that? Got that? Okay, great. Thanks. Sorry. Guess we have a little lesson going on here. Okay, welcome to our lesson on ratios. You're going to need a notebook or your notes, a pencil or something to write with, and you're going to need Smarties. Small pack of Smarties. Go get that if you don't already. We're going to start with a review of essential skills. Here's a ratio word problem for you. A recipe uses 1 cup canned soup for every 2 cups of water. How many cups of canned soup should you use if you have 4 cups of water? Answer that problem. Go. Okay, welcome back. I'm going to try to write down an answer here on the board here. This isn't going to work super well, but I'm doing my best. So if our recipe used 1 can soup for 2 cups of water, then we would have a ratio of soup to water as 1 to 2. So how many cups of soup should you use if you use 4 cups of water? Well, if we used 4 cups of water, then that's 2 times 2 is 4. So 1 times 2 is 2. So your answer is 2 cans of soup. All right. How do I erase this now? All right, I figured it out. So that's an example of a ratio. So I want you to take a moment and write down anything that comes to mind when you hear the word ratio. It could be like something you used to learn. Maybe it's a connection in a movie. Any connection with the word ratio. Go. Okay, welcome back. Maybe compare your list with the friends. See what you know about ratio. What do you think? Do you agree or disagree with each statement? Could you explain your thinking? 1. If you want to measure exactly 100 milliliters, it is more helpful to have a spoon that holds 20 milliliters than a spoon that holds 30 milliliters. What do you think? 2. A recipe requires 1 scoop of sugar for every 3 scoops of flour. So you should use 3 scoops of sugar if you use 5 scoops of flour. Do you agree? Do you disagree? 3. To draw a diagram of your school, it makes more sense to let 1 centimeter on the diagram represent 1 meter than to let 1 centimeter represent 10 centimeters. Interesting. 4. 1 spoonful of sugar in a large drink tastes as sweet as half a spoonful of sugar in a small drink. What do you think? Do you agree? Do you disagree? So this is what our outcome is this week. It's called ratio. Demonstrate an understanding of ratio concretely, pictorially, and symbolically. This is outcome number 5. And our picture that goes with this is this little one of dogs and cats. I wonder why. Here is a definition of ratio. A ratio compares 2 things that are measured in the same units. You can have either part to part or part to whole ratios. They're read A to B, and they're written A colon. Is that a colon? A, that mark, B. So for example, in this picture, the ratio of dogs to cats is 3, 1, 2, 3, to 2, 1, 2. The ratio of dogs to animals is 3, 1, 2, 3. Nope, that's not dog. 1, 2, 3, to 5, because there's 5 total. So that's what a ratio is. It's a comparison of 2 things that are measured in the same units. So I have an example here. I'm going to go into full screen for this example. Okay, so there's an event at the Arctic Winter Games, and it's called the airplane. And what it is one person is the airplane. You can see that guy. And then there's 3 team members that fly the person around the room. And the team that flies the airplane the farthest wins. So you can use a ratio to compare the number of airplanes to the number of other team members. So the part-to-part ratio of airplanes to team members would be 1 to 3, right? Because that's what it is. Question is, what other ratios can you use? Oh, can I move myself? Oh, look at that. What other ratios can you use to describe a team in the airplane event? Think about that. What other ratios could you use? Other part-to-part or part-to-whole ratios. You don't need to answer it because we're going to model it. Our friend Daniel is going to give us an answer. Daniel says, I can use the part-to-whole ratio of 1 to 4 to describe a team. And I'll model this ratio using 1 blue counter to represent the airplane and 3 red counters to represent the other team members. You can see there's 1 blue counter and 3 red counters. I can also use the fraction 1/4 to describe the part of a team that is the airplane. And this is where Daniel's bringing in the idea that ratios are related to fractions. Fractions are a comparison of parts to whole. Ratios can be comparisons of parts to whole or part to part. And in this case, you could use a part to whole relationship of 1 to 4 to describe the airplane to the whole number of team members. Okay. Communication tip. Before you write the numbers in a ratio, you may want to write in words that the numbers describe. For example, if you are describing a group with 1 peach and 6 apples, you could write peaches to apples is 1 to 6. So look at those 2 pictures there. Which picture shows the ratio of 1 to 6 that's described? The top one or the bottom one? Just shout that one out. Shout that answer out. Okay, now it's time to do some guided practice. This is where the Smarties come in. So at your desk or wherever you are, using Smarties, model each of these part-to-part ratios. And then once you've modeled it, then sketch each model. So A is 4 to 3, B is 1 to 7, C is 3 to 5, and D is 6 to 4. So use Smarties to model. Go. Welcome back. I hope you had some fun with that, and I'm sure you could probably eat your Smarties now. You can do this, you can show ratios with anything. Just Smarties are a delicious way of doing it. Okay, so that's our first little section of our ratios lesson. If you want to pause and do some questions to check whether you understand this, now would be a good time to do that. Or if you wanted to continue with the second part of the lesson and then come back to do your questions, that is an option too. So that's something either you as a learner or your teacher can decide. But more practice is on page 180 to 181, or if you can zoom in and read this right here. But I am going to move on to the second part of ratios. I have a question for you. What do these have in common? So maybe have a class discussion about that, point out and jot down some things that these 4 objects have in common. Are there 2 of them that kind of go together and 2 others that go together for any reason? What do you notice? So one thing that I noticed, and the reason I use this as an example, is that the size of the iPhone is in a way the same as the size of this screen. What? That's not the same size at all. The iPhone's way smaller than the TV. That's true, but the shape, this rectangle has the same dimensions as this rectangle. It's just sideways and blown up bigger. Those of you that like technology, you might know that that's called the aspect ratio, and that new technology has a widescreen aspect ratio, whereas Older technology or technology that likes to have a wider screen has a wider rectangle, a 4:3 aspect ratio. Go ahead, ask your parents. Was your TVs always been widescreen like this, or did they used to be more like squares like this? Okay. So this is called an equivalent ratio. So if you Google what are the ratios of iPhones and TVs, this is what comes up on Google. So as you can see, the iPhone 7 Special Edition, those all have an aspect ratio. Let's zoom in here. An aspect ratio of 16:9. That means no matter how big it is, it's always going to be 16:9 as a ratio. Whereas the iPad Pro has an aspect ratio of 4:3. And it's kind of interesting because standard TVs also have an aspect ratio of 4:3, whereas widescreen TVs have an aspect ratio of 16:9. You might notice that sometimes you play a new movie on an older TV or an older movie on a newer TV, and there's like these black lines that take out part of the screen. That's because of the aspect ratio. They look like this, right? Because you can see over here, my aspect ratio for my slides is 11 by 8.5. So it doesn't actually fit perfectly in my screen. That's something to think about. Why do I make my slides 8.5 by 11? Okay, I'm moving on. All right. So an aspect ratio is used to compare the width of a rectangular movie, television, or video screen to its height. The aspect ratio for this screen on the left is 4:3 because there's 4 centimeters of width for every 3 centimeters of height. The television screen below also has an aspect ratio of 4:3, but it is 33 centimeters high. So the question is, how wide is the television screen? Again, you don't need to pause and answer this, although it might be productive for you to take a minute and actually think through how you might answer this question. But we're going to have our friend Robin give us her solution. Robin says, to figure out the width, I'd start by drawing a point for the bottom left corner of the screen. From this point, I'll draw a 4 centimeter line to the right and a 3 centimeter line up. Okay? Sometimes in your first stage of problem solving, it really helps to draw it out to just help understand the problem. Then I'll repeat what I did. I'll go right 4 more centimeters and up 3 more centimeters. Okay, you can see she repeats what she does here and here. And this is helpful in problem solving because she's making a problem simple to more complex to more complex. I can record the widths and heights in a table as I keep going to the right and up. Okay, so Robin makes a table, aspect ratios. She has width, height, and the aspect ratio. So she goes 4, 8, 12, 16, 20, 3, 6, 9, 12, 15, and then she builds her aspect ratio the whole time. 4:3, 8:6, 12:9, 16:12, and 20:15. I can figure out the width and height in each row by using multiples of 4 and 3. For example, the width and height in the second row are 2 times 4 and 2 times 3. Since 33 is equal to 11 times 3, 33 will be the height in the 11th row. I can multiply 11 by 4 to figure out the width. 11 times 4 equals 44. 44 to 33 and 4 to 3 are equivalent ratios. The television screen is 44 centimeters wide. Excellent work, Robin. So an equivalent ratio is ratios that describe the same comparison. For example, 1 to 2 is equivalent to 5 to 10. If there's 1 blue square for every 2 red squares, then there are 5 blue squares for every 10 red squares. And this image shows this really clearly. The ratio 1 to 3 is equivalent to the ratio of 5 to 10. This is a great opportunity to pause and jot down the definition of equivalent ratios, maybe draw that picture. It's great. You can just pause. You can re-listen to things. These videos are great. Okay. Communication tip. You can use an equation to show that 2 ratios are equal, just as you can use an equation to show that 2 fractions are equal. For example, 5 to 10 is equal to 1 to 2, just as 5/10 is equal to 1/2. All right. We're going to model a problem. List 4 ratios that are equivalent to 10 to 4. Again, I'm using my laptop pen, so it's not going to be perfect, but I'm doing my best. So first I need to understand what this problem's asking. Oh, and if you're in class, you can just pause it and do it, your teacher, and then skip past this. Anyways, list 4 ratios that are equivalent to 10 to 4. So the question is asking us, what are 4 other ratios that are equivalent to 10 to 4? If I forgot what the word equivalent meant, I could literally go back 1 slide, 2 slides, and remind myself, oh, an equivalent ratio is when one ratio is the same as another ratio, like 1/2 is the same as 5/10. Okay, so 4 ratios that are equivalent to 10 to 4. All right, I'm going to start by writing out my ratio, 10 to 4. Then first, I'm going to see if I can make it any smaller. One thing I noticed is that both of these numbers are even. 10 is even and 4 is even. So I could split them both in half. So half of 10 is 5. And half of 4 is 2. So that's one equivalent ratio. 5 to 2 is equivalent to 10 to 4. I can't split, well, I could split both of these in half again, right? I could say that half of 5 is 2.5 and half of 2 is 1. And that could be an answer. I'll write it out here just as an example. But I don't think it's a great strategy to start working in decimal numbers when we could do something easier. But 2.5 to 1, or 2 5/10 to 1, is equivalent to 5 to 2, which is equivalent to 10 to 4. But I think the easier thing to do is start multiplying. So if I did 10 times 2 times 2, I get 20. And if I do 4 times 2, I get 8. That's 4, but I want to just give you one more just to do it. And what I want to point out is that I could double this one again, but it would get quite big. But I'm just going to. That works. So 20 times 2 is 40. And 8 times 2 is 16. So there is one way of solving this problem. List 4 ratios that are equivalent to 10 to 4. Okay. So more practice on equivalent ratios can be found on page 184 and 185. Again, if it's good for you to pause and work through some questions, now would be the time. Or if you want to continue with this lesson and then come back to these questions, that is an option too. The only option that's not an option is never looking at these questions. So anyways, moving on. Here we go. Your key practice for this outcome are these 4 IXL skills. Grade 6 P1, where they ask you to write a ratio. Grade 6 P2, where they ask you to write a ratio but in word problems. Grade 6 P3, where they ask you to identify equivalent ratios. And grade 6 P4, where you write an equivalent ratio. So IXL is your key practice. Make sure that you're trying all 4 skills. It'll take a lot of work to get to mastery, but if you get to like a 60 or 70 in a skill, then maybe move on to the next skill and come back to it. But those 4 skills are your key practice for this outcome. Your key problem, I don't know why that says sleeping, so please ignore that. Let's just go ahead and just ignore that. I think I had some different problem in mind, but I went with this one. Written in lowest terms, what is the ratio of squares to circles shown below? Okay, so that's your key problem. Make sure that you work on that and get some feedback from your teacher. And then when you're finished your key problems and your key practice, then you are invited to explore more about ratios. We have bonus slides, math focus pages 174 to 185. On ST Math, there's some skills called applying rates and ratios. And on Celero, you can go into number and look for ratios. So that's the lesson. Go ahead and get to work now. Your first task is to practice these key practice problems. Then look at this key problem. And then after that, go ahead and explore more. I'm going to continue recording and just look at a couple of the bonus slides because I want to explain them, but just use that later. This video is kind of a funny one from ST Math. Check that one out. There's another example that we can think about with basketball players and hair colors and extrapolating for the whole school. We have some vocabulary cards if you want to make some cue cards. Those are those. There are 3 math books for this unit. Gulliver's Travel, which is a classic. Roll of Thunder, Hear My Cry, I haven't read. So if you want to read that and let me know how that is, please do. And The Shrinking of Treehorn. I have all 3 of these books in my class, so feel free to come ask for them. Like I said, ST Math has some skills about applying rates and ratios. This little wormy. There's also tables and graphs and these little plants. Proportional reasoning is kind of the same thing. There's these ghost aliens. How many mouths and arms do they have? Numbers and proportions, very similar. And that is what we have for our bonus. But if you find something else that you think is awesome, send it to me and I'll put it on the slides. All right. I guess that is all. I'm going to go enjoy my Thanksgiving dinner. Thanks for watching.